6.3 Graphs of sine and cosine functions. So starting into sine and cosine functions, I want to talk about periodic functions. Periodic functions are those that repeat themselves over a certain every certain amount of time or period. So making it a periodic function just means that it does the same thing over and over and over again. Now when we're talking about sine and cosine functions, they have a period of 2 pi. Or if you're in degrees, 360 degrees. But we're going to deal with radians as we deal with this. So they have a period of 2 pi. Now sine and cosine functions, since they have a period of 2 pi, that means every 2 pi, they're back at where they started and they keep doing the same thing over and over again. So you can really say that sine x is equal to sine of x plus n times 2 pi. And cosine of x is equal to cosine of x plus n times 2 pi. So if we take x and we add 2 pi to it, we end up back in the same spot. If we add another 2 pi to it, so n being an integer, I should specify that, n being an integer, then every 2 pi we're back at the same spot in the cycle. Thus we have a periodic function. Now the sine function, let's give myself a graph here. Sine function, we already talked about sine as a trigonometric function and said if it hasn't been modified by any change in amplitude, multiplying by something to stretch or shrink it vertically, then it has a max of 1 and a minimum of -1. And remember that the domain of a sine function is from negative infinity to positive infinity. And the range we said is from -1 to +1. Now the sine function, I'm going to say, remember that it's a period of 2 pi, so I'm going to come out here and make that 2 pi. Halfway to that is pi. Halfway to that is pi over 2. Let me just put little lines instead of dots necessarily. And then halfway between pi and 2 pi is 3 pi over 2. So just to give us these measurements here. So sine starts at 0. So it starts at 0. And then at pi over 2, it's at 1. At pi, it's back to 0. 3 pi over 2, it's down to -1. And then at 2 pi, it's back to 0. So we have those 3 points. And it passes, so it goes up and passes through this one, comes back down, passes through this one, goes back up, and there we have a sine wave, or one period of a sine function. Now because of this repetitive shape, many times we refer to things as being a sinusoidal wave, if it kind of goes up and down and up and down and up and down and just continues through that. So many things that we deal with, if you deal with notes or tones, those are certain frequencies and they're sinusoidal waves. We get a mix of those sinusoidal waves to give us more variation in the tones. You got multiple tones going at the same time or different amplitudes involved with that. But that's our sine function from 0 to 2 pi. It follows the same pattern back too, because remember I said that it's sinusoidal. So if I go back to negative pi over 2, then it's going to be at -1. If I go to negative pi, then it's going to be at 0. If I go to negative 3 pi over 2, then it will be at +1. And then to negative 2 pi, it will be at 0 again. And we see that it follows through the same process back that way, and it's just this continuous function. We can also take note with this that the sine function is symmetric with respect to the origin, meaning that f of negative x is equal to negative f of x. So if I put a negative value in for x, like that negative pi over 2, we got the negative of f of x. At pi over 2, we have 1. At negative pi over 2, we have negative 1. So this is symmetric with respect to the origin, otherwise known as an odd function. So that's the sine function. Cosine function, very similar. I'm going to leave my measurements in there because I'm just going to use those again. I'm going to try to leave them in there somewhat without making too much of a mess. The cosine function starts at 1 when x is equal to 0. Cosine is equal to 1. At pi over 2, x is equal to 0. At x equal to pi over 2, the function f of x is equal to 0. At pi, we have negative 1. At 3 pi over 2, we're back up to 0. And then at 2 pi, we're back up to 1. And therefore, we have this, looks a lot like the sine wave, doesn't it? The difference being that we started at 1. And then went down to 0, went down to negative 1, back up to 0 and 1. So there's not a lot of difference in it, but if we follow the other direction, we see that it will do the same pattern. Not the best job I've done of drawing that. This one got a little carried away, but we're not too bad. So we can see here that when f is equal, when we take f of negative x, we get f of x. So the cosine function is symmetric with respect to the y-axis, or it's an even function. So we can see that it works. Again, it has a period of 2 pi, and we just split it into the pieces there. And so the domain is from negative infinity to positive infinity. Again, this repeats every 2 pi, and the range is from negative 1 to positive 1. So sine and cosine aren't that difficult to work with. I'm just going to put sine back up here. And remember, it was 0, 1, 0, negative 1, 0. And I'm going to point something out to you. When you're graphing a sine wave, when you're at the maximum and minimum values, or when graphing a cosine wave, same thing, it passes through that point horizontally. And I point this out because just like when we were dealing with the circle or other shapes, and we mentioned these things, it makes it much easier to draw it because we're going to come at that from the side and make sure we go through it horizontally. Then go through here and make sure we go through that one horizontally. And it ends up looking more like a sine wave than a triangle wave, which we do not want it to look like. Now, the reason I show this on the same graph is I want you to notice that sine and cosine are really the same function, just shifted pi over 2. So you can say that the sine function is cosine function with a horizontal shift to the right of pi over 2, or the cosine function is the sine function with a horizontal shift to the left of pi over 2. So they're essentially the same function, it's just where you start with it. And that, of course, all comes from the fact that if you look at the unit circle, cosine is the x value and sine is the y value. And you can see that that's going to put you through this phase shift here. Okay, so now that we've got that, we can actually graph some modifications of sine and cosine functions. And the modifications I want to deal with are a sine x or a cosine x. And that's not arc sine, okay? Just don't get confused with that. That is a as in a constant a. So a sine x or a cosine x. And sine bx or cosine bx. Now, as we've dealt with in the past, if you take a function and then work on the output of that function, in this case with a, we're multiplying it by the output of sine x, then that must be dealing with the vertical. So we're multiplying, right? So that's a vertical stretch or shrink. If a is greater than 1, then it's a vertical stretch. If a is between 0 and 1, then it's going to be a vertical shrink. If you put a negative sign in front of it, it's going to flip it over the x-axis. Now the b in here, that's affecting the input x. So we know that if you affect input x, that's going to affect the horizontal. So this is going to be a horizontal stretch or shrink. So if b is greater than 1, then it's going to be a horizontal shrink. Remember that horizontally things work opposite of what you're used to, or what you would think of intuitively. And if it's between 0 and 1, then it's going to be a horizontal stretch. And it works the same for sine and for cosine. So they work exactly the same. The nice thing about dealing with this this vertical stretch or shrink, is since cosine and sine have a range from -1 to +1, this a just gives you your new amplitudes. So if a is equal to 3, then it's going to go from -3 to +3. If a is equal to 1/2, then it's going to go from -1/2 to +1/2. So that makes this one really easy to deal with. This one is the one that takes a little bit more effort, but not a lot more effort. We said the period of a sine or cosine wave is 2 pi, or a sine or cosine function is 2 pi, which is good. When we put this b in here, that's going to affect that period, and it is simply the new period is 2 pi divided by b. Since the original period was 2 pi, this b is just going to divide into it to tell us the new period. So if b was equal to 2, then the period 2 pi divided by 2 would give us a period of pi. So those are the two that we're going to focus on right now, and you'll see that they're really not that horrible to work with. And I'm going to show you the really quick, easy way to be able to graph a sine or cosine function. Some people go through and they want you to plot, they try to plot points and they try to do all these things. You don't have to do all that. Anytime you are plotting a sine wave or a cosine wave over one period, you just need 5 points. And those 5 points I've already shown you when I graphed them initially. So we're going to do the same thing. So let's say we have 5 sine of x. Well, if we have 5 sine of x, and we want to graph one period of this, I'm just going to make that statement. Sometimes I may require you to graph one period, sometimes 2 periods. Please read the instructions to see how much you're supposed to graph. Or you may be told to graph over a certain interval from negative pi to positive pi. So please just be aware of what you are supposed to be graphing. So we're going to do one period of this. There is no b here, or b is equal to 1, so it's going to have a period of 2 pi, which is what we've seen before. 5 is a, that's our amplitude, so that just means we're going to have 5 as our maximum and negative 5 as our minimum. So we're going to treat it the exact same way we did before. Now the 5 points that I always graph to graph any sine or cosine function are, I take the period, we know with this, the period is equal to 2 pi, t stands for period, just letting you know that, okay? So the period is 2 pi, so I am going to put 2 pi, and then I'm going to take the halfway mark on that, which is pi, and then the halfway mark of that, which is pi over 2, and then if that's pi over 2, that's 1 pi over 2, that's 2 pi over 2, that's 3 pi over 2. And we now have 1, and remember that's 0, I usually don't write that in, okay? But 0, pi over 2, pi, 3 pi over 2, 2 pi. So that's 1, 2, 3, 4, 5 points. And what does a sine wave do? Well, a sine wave is going to start at 0. It's going to go to its peak, so 5. It's going to go back to 0. It's going to go back to its minimum of negative 5. And then it's going to go back up to 0. And then we draw our curve. Make sure that you're putting it horizontally through the maximum and minimum values. And that looks pretty much like a sine wave. And it's not because I'm awesome at drawing these, it's just I know that I'm going to go through these at a slant. So don't try making this a vertical line here. This is going to go through at a slant. When I cross 0, or the x-axis, I'm going to go through slanted. That's okay. But I focus on the fact that my peak, both max and min, goes horizontally at that point. And so I just make sure that I give myself enough space that I can go horizontal at that point, come through an angle, horizontal at that point, come up back up at an angle. Now you see, that's it. That's 5 sine of x. Well, let's make it more complicated. Cosine 4x. So cosine 4x, no amplitude. Don't like this marker, gonna get rid of it. There we go. So there is no a in front, so it's just gonna go from negative 1 to positive 1, so we're good there. 4x, so we have b is 4, so our period is equal to 2 pi divided by 4, which is equal to pi over 2. Okay, we know we're dealing with positive 1 and negative 1. Our period is pi over 2, so I'm going to come over here and put pi over 2. Half of pi over 2 is pi over 4. Half of pi over 4 is pi over 8. 1 pi over 8, 2 pi over 8, 3 pi over 8. Notice that I start with my period, I divide it in half, and I divide it in half. So that gives me 3. This is 0, so I don't bother writing anything down for that. But I start with the period, divide in half, divide in half. And then I use this to get this one just by counting. I have 1 pi over 8, 2 pi over 8, 2 divided by 8 is 1 over 4, right? Pi over 4. 3 pi over 8, so I just go 1 pi over 8, 2 pi over 8, 3 pi over 8. And I've got all my pieces. Now I just have to remember what cosine looks like. Well, cosine starts at 1, or I should say starts at the peak, the maximum value, goes through the x-axis, goes to the lowest value, goes through the x-axis, goes to the highest value. And then it comes through the max and min horizontally, so I go through that, come down, go through that horizontally, come down, up, and go to that horizontally. And I've got cosine 4x. But you see how easily that comes together? I don't have to do any fancy math. I don't have to go through and start plugging things into my calculator to figure out where to do it, because I know there are 5 points that are always going to occur on a sine wave or a cosine wave. So all I need to know is where each of those points exist, starting with the period. Divide in half, divide in half. 1, 2, 3. Get those, and then just draw my thing. Maximum, minimum values. So let's do one more of these. Three sine two pi x. 3 sine 2 pi x. Okay, so we've got an amplitude. I can even just say A for amplitude, an amplitude of 3. The period is going to be 2 pi divided by 2 pi, which is 1. And it's a sine wave, so I'm going to do this. We have an amplitude of 3, so that's going to be 3 and negative 3. We have a period of 1. Half of 1 is 1/2. Half of 1/2 is 1/4. 1/4, 2/4, 3/4. And then because we've got that, it's a sine wave. It's going to start at 0. Go to the maximum value, go to 0, go to the minimum value, go back to 0, go horizontally through that peak, come back down, aim for the other one, go horizontally through that, and come back up, and we've got 3 sine 2 pi x. Yes, it's that easy. So if you've been taught these fancy ways to do this, where you have to do all sorts of complicated stuff, stop doing that. Do it the easy way. I mean, yeah, I admit it. This point right here probably is not exactly where it's supposed to be. I'm not too upset about that. Okay? And you don't have to be either. In fact, and we're not going to really go into this step here, we could do something like this. 2 cosine pi x minus 1. We just added a c to this. We added a vertical shift. Horizontal shift gets a little more complicated because we have to deal with b and how it affects that. So I'm not going to worry about it at this point. And I'm not going to test you on this either. But it's just something to show you and show how easy it really is to do this. And remember, when I say easy, that means when you understand it and it clicks, so it all makes sense, it's easy. Until that point, feel free to understand it's hard, okay? Everything's hard until it becomes easy. Once these things that I've just taught you make sense and they click, then you go, that's all I gotta do. Until then, you're like, what the heck did he do? And that's okay to be confused for a while, but please try to get past that stage. So we got 2, a -2. What the heck? Let's put a negative in front of that 2. Make it -2 cosine pi x minus 1. So our amplitude is equal to 2. There's a negative sign, so it reflects. So we're going to reflect it over the x-axis. So we're going to flip it vertically. Okay. The period is equal to 2 pi divided by pi, or 2. And then it's going to move down by 1. Down by 1. And that's what's going to happen with it. So let's go through this. Well, we've got a period of 2. So there's 2. Half of 2 is 1. Half of 1 is 1/2. 1/2, 2 halves, 3 halves. See how that always works? Period. Divided in half, divided in half. Whatever this half is, it's going to be 1 something or another. 1 pi over 2, 1/2, 1 pi over 8, whatever it happens to be. So 1/2, 2 halves, 3 halves, 4 halves. Always work. So I'm going to do this in 2 steps now. I'm going to start with drawing, well actually I'm going to do it in 3 steps. Let me do 3 steps. 1, I'm going to start with just 2 cosine pi x. So cosine starts high, goes to 0, goes low, goes back to 0, goes high. And I'm going to dot that. You don't have to dot it. If you're using this method to shift things around, you don't have to dot it in between as long as you indicate which one's the final one. I chose to dot it. Okay? Next thing I'm going to do is I'm going to do this flip over the x-axis. That's tied to this cosine function before this -1 is. So make sure that you just do that first. So I'm going to flip it. So now it's going to start low. Go to 0, go high, go to 0, go low. Oops. So busy doing my dots. So it goes through there horizontally, right? It's going to go through there horizontally. Going to go through there horizontally. So there we go. So now I flipped it over the x-axis. Last thing I need to do is shift down by 1. So if I move it down by 1, that means I'm going to have 1 for the peak, and I'm going to have -3 for the minimum value. We're dealing with this red one, shifted down 1, so it's going to be 0. I'm going to put a -1 here just because that's going to make it easier, because instead of crossing the x-axis, it's going to cross the line y equal to -1, and then it's going to peak at +1. It's going to cross the line y equal to -1, and then it's going to make it down to -3, and then goes through horizontally, goes up, through horizontally, comes down, through horizontally, more or less, and we have -2 cosine pi x minus 1. To me, this is one of the most fun things to deal with because, as I said, once you understand how it works, you can deal with any modification of a sine or cosine function and graph a very close approximation. I'm going to say approximation because remember what I said, I'm not graphing any of the in-between points, so I'm not really where I would expect. When I'm at pi over, if I'm on a standard sine function, I'm not going to be at the right value at pi over 4, but I'm going to be darn close. Now, one other thing I want to cover, sorry I need to step away so I can do it, is what if we are given a graph of a sine or a cosine function, and we need to determine out what the equation is. So I'm going to give us this graph. Okay, more or less. So here's our graph, and we want to determine what the equation is for this function. Just going to toss away my piece of paper there. There we go. So we want to find the equation for this. Well, what do we need to know? First, we need to know, does it look like a sine wave or a cosine wave? It starts at 0, goes high, it goes back to 0, goes low, goes high, right? So it's a sine wave. That much I've got. It's a modification of sine x. Okay, because it started at 0 and then it went to one of its peaks and continued back to that. Cosine would have started high or low. Second thing we want to take note of, is it going in the normal direction? Sine starts at 0, goes up, and then back to 0 and down, normally. So if it had gone down and then up, then we would have said we have to flip it, make it negative, but it goes in our normal direction, so we're good there. We don't have to flip it over the x-axis. What about the amplitude? Well, it looks to me like that amplitude, it's about halfway. It's not perfect over here. My -1 was a little low, but in comparison it is. So that's at 1/2 and -1/2. So A is equal to 1/2. That's our amplitude. The other thing we need to know is the period. Well, it starts here and it goes up, down, up again. So the period is equal to pi. So they have the period. So now that we have that, we have our amplitude, we have our period, we need to find B. Because the amplitude is going to give us A. We need to find B. Well, we know the period is equal to 2 pi over B. So if the period is pi, then we can say that pi is equal to 2 pi over B. Multiply both sides by B. B pi is equal to 2 pi. Well, that's going to be pretty straightforward, right? Divide both sides by pi. B is equal to 2 pi divided by pi is equal to 2. So now we have B equal to 2. So the equation for this sinusoidal function is 1/2 sine 2x. And I can put that as f of x is equal to, because it is a function, right? Sine function. Note it is not a one-to-one function. The only way it can be one-to-one is if we take only a section where it is one-to-one. So there we go. 6.3, graphs of sine and cosine functions.